Without further ado, let's welcome the author of Connected, The Surprising Power of Our Social Networks and How They Shape Our Lives, Professor Nicholas Christakis.
So thank you very much for that introduction and a very warm welcome. I'm interested in speaking to you today about the kinds of social networks that we human beings have been making for tens of thousands of years, ever since actually we emerged onto the African savanna, and not just the recent online variety. And I've actually spent the last few years researching social networks and how and why we human beings assemble ourselves into these networks and how they affect our lives, our health, our desires, our feelings, our thoughts, and our actions. And here's what they look like. Every dot is a person. Every line between them is a relationship between two people. And they're these intricate things of beauty. And they're so elaborate and so complex and so ubiquitous, in fact, that you have to ask yourself, why do we do this? Why do we make these networks? What purpose do they serve? What do they offer us? Why are we embedded in them? And so the questions become, how do they form? How do they work? And how do they affect us? So one way they affect us is by exposing us to phenomena that are spreading within them, from germs to ideas to emotions. And a lot depends, with respect to our own lives, on what's happening in the lives of the people around us, the people to whom we're connected. And this is one of the first images we made to study this type of thing. It's the first network map of human emotions. Every dot is a person. Every line between them is a relationship between two people. And here we color the dots according to how happy people are. So yellow dots are happy people, and blue dots are sad people, and the green dots are in between. And if you look at this image, you probably can see that there are clusters of happy and unhappy people in the network. And these clusters, it turns out, spread to about 3 degrees of separation, such that the happiness of every individual is associated with the happiness of the people to whom they're connected, their friends, and their friends' friends, and their friends' friends' friends. And these clusters can arise for several kinds of reasons. First and most obviously, from a kind of birds of a feather flock together phenomenon, homophily or love of like, the preferential attachment of happy people to happy people, and perhaps unhappy people to unhappy people. A second way is through a kind of contagion or induction effect, such that my happiness affects the happiness of other people to whom I'm connected. And a third mechanism is that all of the people in a cluster are simultaneously exposed to something that's making them all happy or all unhappy at the same time. And mathematical analyses suggest that all 3 of these phenomena are present in social systems. But the key point is that your happiness doesn't just depend, for example, on what's happening in your own body, on your own physiology, or on your own choices and actions, but can come to depend on the physiology and the choices and the actions of other people to whom you're connected, and even people you don't even know, such as your friends' friends or your friends' friends' friends, through a kind of cascade effect through the network. Also, you might notice if you look at this image that the blue dots are more likely to be located at the periphery of the network. They're structurally more at the margins. Another way that networks can affect us, however, is not just by providing a mechanism by which things can spread and reach us, but also by their very structure. And this is some work done by Brian Utsi at Northwestern University. He became very interested in how Broadway musicals are successful, in the commercial success and in the critical acclaim of Broadway musicals. So he mapped the networks of the production companies, the director, the producer, the actors, and so forth, and he computed something known as the density. And on the far left, you'll see a little cartoon of 5 people that are in the production company and who they knew from before. And in the middle, you see one person, you see 5 people to whom that person is connected, and they're 5 times 4 divided by 2, 10 possible ties among those people. And in the far left, none of them exist, so it's 0% density. And the next cartoon over to the right, 4 of the 10 ties exist, so 40% density. And the next cartoon over again, all 10 of the ties exist, so 100% density. And on the far right, he plotted on the x-axis the density of the production company, and on the y-axis the financial success and critical acclaim. And he found this shape that's shown on the graph. If nobody knew each other from before, and there was 0% density, the show was a flop. And if everybody knew each other from before, at the other end, the show was a flop. And the optimal performance was achieved when you had middling density in this situation. So people can be organized and connected in particular ways, and this itself can affect what we are able to do. And when I said that we humans have been making social networks for tens of thousands of years, I actually wasn't kidding. We recently mapped the social networks of the Hadza. The Hadza are a hunter-gatherer population. There are only about 1,000 of them left on the planet. Less than 500 of them live in the traditional way around Lake Eyasi in Tanzania. And they roam around this place, hunting and gathering for their food. They have no significant possessions. They sleep out under the stars. And they live, as near as we can tell, the way we humans lived tens of thousands of years ago. And we took a photographic census of the Hadza, and we made a kind of Hadza Facebook. And we took posters of this Facebook into the field, and we asked all the Hadza to tell us who were their friends in a number of ways. And so there's Corin Apicella, my postdoc in the lower right, showing a Hadza person the photographs and eliciting who their contacts are. And when we mapped these networks, we discovered something that to us was very amazing. Namely, that on both visual inspection and mathematical analysis, these networks look just like ours. The structure of these social networks were indistinguishable from the structure of networks seen in modernized settings. And while we were there with the Hadza, we also measured another important property that's part of the story, namely their tendency to cooperate with each other. And now in this graph, I show the shape and color, the size and color of the dots indicates how cooperative these individuals are. Bigger dots are more cooperative people, and the yellow dots are the most cooperative, then the orange dots, then the red dots. And if you look at this image, you can see perhaps that there are clusters of cooperative and uncooperative individuals within the network. Cooperators tend to cluster with other cooperators together within this social fabric. People seem to assemble social networks so that they are connected to others who will reciprocate their kindness, and this allows them to be better off than they otherwise would be. And still other work of ours has demonstrated that there's a partially genetic basis to human social network structure. And we can begin to imagine a kind of collective phenotype that we evince, not just individual phenotypes. Still, what's the point of a connected life? How does it help us as individuals and as a species? And it turns out that networks are a resource that we can all use. They're a kind of social capital. And most people, when they think about capital, think about money. But really, capital is any stock of resources that can be put to productive use. And two further subtle ideas about capital are that in order to acquire capital, you have to know something and do something. And second, that you have to work upon the world and transform the material world. You have to introduce changes into a substance to make it yield a higher rate of return than it otherwise would. So for example, a farm is a stock of capital. By investing skill and labor to clear the woods, one makes the land more productive, at least of fruits and vegetables and grains, than it otherwise would be. So land, especially improved land, is a form of capital. You've known something and done something, you've invested, you've acted upon the world, you've transformed the world, and now you have something that's valuable. Or take this example, you can take a tree and invest skill and effort and convert it into lumber, which is a stock of capital that can be used in ways that a tree cannot. Such as, for example, the lumber is now a reservoir of wealth. And you can use it to do new things, like make a violin, by investing still more skill and effort. And this violin can now do things that the lumber could not, like make music. So capital is a change that allows a substance to act in new ways. And that is part of what makes it a store of wealth and a source of productive power. Now, a key innovation in the social sciences, in thinking in the social sciences, took place in the 1960s, and we began to see people and their skills and talents as a form of human capital. And the chief example of this is education. So you can take this dissolute former graduate student of mine on the far left, who's a drunkard, and you can clean him up, get rid of the beer and the toothpick, into the middle, and you can invest skill and effort, and he becomes more productive than he was before. Or you can invest still more skill and effort in him and give him an education. You can change his mind. You can work upon the material substance of his brain and rewire his neurons in a fashion that makes him still more productive than he was before, and this makes him a stock of human capital. Now, just like physical capital is created by a change in the material world, and human capital is a change in persons, social capital in organizations, in communities, or in the whole of society is a change in the relations among persons, a change that renders the group more productive and capable of doing things it was previously not able to do. And I, in fact, think that we have evolved to create this kind of social capital, to assemble ourselves into kinds of networks that maximally create particular kinds of social capital. So let me close by illustrating it with this point. Think of these two objects. They are both, as you all know, made of carbon. And the difference between these two allotropes of carbon is that the way the carbon atoms are connected to each other. On the left, we have graphite, which is soft and dark. And on the right, we have diamond, which is hard and clear. And there are two key ideas here. First, these properties of softness and darkness and hardness and clearness do not inhere in the carbon atoms. They are not properties of the carbon atoms, they are properties of the collective. And second, which properties you get depends on how you assemble the carbon atoms, how you connect them to each other. Similarly, the pattern of our connections among ourselves affects the properties of our social groups. It is the ties between people that make the whole greater than the sum of its parts. New properties, like social capital, but not limited to it, emerge because of the connections, because of the ties between people, and not necessarily because of the people themselves. Our experience of the world depends on the actual structure of the ties around us, near and far. And we make these ties in particular ways because they benefit us and because I believe we've evolved to do so. In fact, overall, I believe that we evolved to form social networks and particular kinds of social networks because the benefits of a connected life outweigh the costs. And this has been true in a way that blows my mind, at least, for tens of thousands of years. Thank you.